Howdy everyone! Welcome back to the Big Lake and Southern Buildout, home of the Little Signal Company. It's been pretty cold around here the last few months, a bit too cold to be working on our layout as much. So today, we're going to take a step back from the layout to tell you more about 3D printing and our signal system. So grab a lantern, hang it on the caboose, and hop aboard because today we will be talking all about lights, camera, and action. Well, maybe just the lights for now. There have been many options for signals that are available on the market, from vendors anywhere from LGB to others that are on eBay, Etsy, or used to be sold by Splitjaw. There have been several attempts to make realistic signals for G-scale layouts. Of these styles, the most prominent systems use infrared, or better known as IR sensors. In other words, it uses a light beam detector to check if there is any movement or object within a certain distance. Though these work well enough indoors, they suffer from a few drawbacks. First, if there's a car that doesn't have a compatible height that passes by the detector, say a flat car without a load, the detector will automatically switch the lighting system to either a timer or another light color inadvertently. Second, when dealing with light sensors, distance is a factor. Things that can affect IR distance detection include smooth surfaces, which have a longer distance detection, versus rough surfaces, which have a shorter distance detection. Color is another factor, where objects closer to white colors have greater reflection distances versus dark colors, which have extremely short detection distances. Increased light can drastically affect reflection and color intensity as well, leading to erratic distance settings. Lastly, electronics do not like weather, especially water. We have found that most of these systems are not rated for outdoor use, which causes corrosion and eventually they end up not working at all. Given this, we tried to approach the issue from another angle. LGB created an interesting signal system using ferrite magnets attached to train cars and engines. While promising as it was, it too had drawbacks where magnets would interfere with other components, cause decoupling, or even cause the train to stop, or so we have been told. However, magnets are great in the fact that they have an invisible field that is unaffected by weather, obstructions, or outdoor light. In the past, these had been paired with something called a reed switch. A reed switch is a magnetically operated electrical switch containing 2 or more ferromagnetic flexible metal reeds inside a sealed glass envelope. Whew, say that 10 times fast. When a magnet is brought near, the contacts close. These are typically used in security alarms, automotive sensors, and fluid level monitoring. This seemed like an okay idea, but we knew we could do better. We started off with neodymium magnets, which are the strongest permanent magnets available, offering up to 10 times the strength of standard ceramic or ferrite magnets of the same size. I hope you are taking notes because there will be a quiz at the end. They are graded from N35 to N52, with the higher numbers indicating greater magnetic energy and pull force. Neodymium magnets, due to their strength, offer clear distinction of magnetic poles. And because we are total nerds, we decided to capitalize on the physics of this and paired these powerful magnets with Hall effect sensors. As a comparison, Hall effect sensors are solid-state, 3-wire devices offering high-speed, contactless, and near-infinite life, ideal for precise, fast-switching applications. Reed switches are mechanical, 2-wire, passive switches requiring no power, best for low-power, simple on-off, or AC-DC switching. No, not the band. The greatest advantage of Hall effect sensors over reed switches is that reed switches suffer from unintentional opening and closing, creating electrical noise. This is also called contact bounce. While Hall sensors offer superior durability and speed. And thus, the Little Signal Company was born with an idea. Supply the world with LED signal lights for G-scale layouts both indoors and out. The problem was that while we figured out quickly how to incorporate Hall effect sensors to do the job, we didn't have a way to house the sensor. So we put on our thinking caps, and while running some trains on our outdoor layout in New Hampshire, the idea came to us. Trains have to pass over track, obviously. What if the magnets were mounted on the bottom of the train, both on the locomotive and the caboose or tail car, in such a way that it was easy to install, didn't require glue or crazy modifications, and allowed the Hall effect sensors to detect the magnets? Turns out there was a simpler solution than we thought. We quickly got to work with 3D modeling software and came up with the holder for a simple sensor. We worked out a Gerber file for having the chips printed, bought some Hall effect sensors, resistors, and got to work with our soldering iron. After about 100 of these being made by hand, we decided to outsource our chip manufacturing to a company called FastLink. Ida, our sales rep, has been such a help to our company. She is amazing to work with and has been instrumental in making our signals more robust, reliable, and consistent in manufacturing. Thank you, Ida and FastLink. We really appreciate you guys. While still working out the details on the chips, we started work on the model designs as well. Initially, we considered signal bridges, signal cantilevers, dwarf signals, targets, and signal light housings for 2, 3, and 4 lights. We also looked into Penn Railroad PL signals. And once the caffeine wore off, we realized that unfortunately, we can't do everything all at once. So, we decided to start with low-hanging fruit, dwarf signals and target signals. While we say it was low-hanging fruit, we went through dozens of iterations of each model system to improve ease of assembly, strength of model, overall look and feel, and had to refer to libraries of photos and plans for measurements to get to where we are now. Dwarfs were much easier being squat to the ground. It made the modeling process a bit more manageable to work with. As you can see, we use 2 LED lights, one red and one green. These power through DC power and utilize a single sensor chip for simple red to green and back again as a train passes over from engine to tail car. For those purists on block signaling systems, sit tight. We will get back to you. The targets, on the other hand, took a lot longer to refine. Countless hours of printing, iterations, and adjustments. It took months for us to have our first working signal. The system is a single LED with dual colors, red and green, attached to the same single sensor block. Creating the mast took a number of tries. The target face we attempted to make concave, but couldn't get it clean enough. The stairs were several dozen iterations to make them flexible enough to not snap when hit, but sturdy enough that they wouldn't just break when touched either. This brings us to today. While we like the 2 light idea, ideally we wanted 3 lights. Red for full stop, track is loaded. Yellow for caution, something is ahead, but you can proceed. And green for full speed ahead. Purists, including ourselves, enjoy the realism of this type of system. Bad news for the true purists, though. We just aren't there yet. We will, however, be offering up a new line of signals that are 3 light soon enough. But before we get to that, if you haven't done so already, pretty please with a cherry on top, like and subscribe to this channel. Our goal is to try and get to 1,000 subscribers, so we need you to not only hit that subscribe button, but also some of your friends and family. I'm sure they will enjoy the entertainment we provide just as you do. Our new 3-light system took us months to work out the kinks with the electronics. We wanted to avoid logic programming if at all possible. That said, we did end up working with a group of engineers who gave us a little assistance with our endeavors and came up with a new light system that can be set to 30, 45, or 60-second delays. The system works similarly to the first systems. A locomotive with a magnet passes over the sensor and the light turns red. Once the tail car or caboose passes, the light will turn yellow and stay yellow for either 30, 45, or 60 seconds. You decide when you order them, before automatically turning back to green. We are allowing for a choice in time so that each user can set the timing based upon the size of their layout. Small layouts would have no reason to have a 60-second delay, but larger layouts may want to have that option. With the electronics now set, we go back to the modeling software and the CSX rail yard down the yard. With the electronics now set, we go back to the modeling software and the CSX rail yard down the road. As with all our models, we want to make our signals as close to scale as possible, 1/27th, and have them look as real as possible, with as much detail as possible. The realism of the signal is what makes the signal worth having. Lights just make it look cool, especially at night. These LEDs really do bring the layout to life. Our designs are modeled after Caterpillar signaling systems. We took the dimensions from their catalog and paired that with these photos and our own measurements. We got to work, and after about 2 weeks of time in the software, we are nearly done with most of the modeling. These signals will be single-mast 2 or 3 light systems. We do plan to consider cantilever systems in the future, but for now, we are going to start here. Modeling takes a lot of iterations and testing to get it right. We approach this from many angles.
Bro, does this look Sigma enough to pass for a skibbity signal? Is this thing low-key plug and play, or am I fighting for my life trying to get it lined up and not crooked AF? Does it actually print clean and work, or is it just a crispy benchy tier L that can't even function?
Does this look good enough to pass for a real signal? Does it assemble easily without struggling to align parts with and square up to signal? Does it even print well enough to be used as a functioning part?
We spend hours trying to get the right combination of all these considerations and so many test prints to get the right look, feel, and ease of assembly. But let's take you on a tour of what the modeling looks like as compared to the pictures they are from. The light fixtures are modeled as close to spec as in the real world as possible, including all the details of access bolts, shape, and additional protrusions. We did not include the hook at the top due to how frail it would look and the likelihood that it would simply break off. We do have some discrepancies, but they are necessary for the function of the print and limitations of the scale. As you can see here, the box isn't quite the same design. This is because we needed to have a large enough diameter to have the wiring come out at the box just as it would in the field. The box has to be assembled from 3 parts. There is the back of the box, which will attach to the mast through a hole as seen in the mast. Then there is the door, which is printed individually so that we can avoid having support on the prints. Lastly, there is the electrical collar, which will have the wires protruding out. We even modeled the detail of the bolts and nuts. We modeled these a little larger though, so that the detail of the hex nuts can be distinguished. We realize they are a bit more cartoony than in real life, but a necessary change to provide the detail we wanted to show. As stated, we went with signals that have the Darth Vader shroud, as it is called. This is actually a snow shroud, but we included it along with the additional sun visors for the lights, which provides a bit more detail in the print model. We are still working out the final model files, adjustments, and changes we want to see. We plan to include a ladder, service platforms, and as much detail in those pieces as possible. While these signals are not yet available, we are taking orders for them and will be shipping them sometime around midsummer once all the kinks and issues have been worked out. The signals will come with an electrical bungalow to house the main chipboard and protect it from weather, with all plug-and-play cabling to and from the sensor and board. We are going to try and incorporate a soft white LED into the bungalow as we see in the field, but no promises yet on this. And with that, we leave you with another video of trains running around on what we have of our layout so far. We are already working on our next video, one where my voice will get to take a break. Stay tuned for that as I have my other half talk about our gardening adventures on the layout. Until next time!